also call it as static CMOS, or we can say that fixed CMOS. The complementary CMOS, we can also call it as static CMOS. Now, let us discuss. Here the pull-up is PMOS network and pull-down is NMOS network. The pull-up is PMOS and pull-down is NMOS. So coming to this truth table, here pull-up is off, which means the PMOS is also off and pull-down is also off. This NMOS is also off. Then what is the condition? So if pull down is also off, pull up is also off, then the output is Z. We can call it as float. Suppose if the pull up is on, which means its value is 1, pull down is off, which means it is 0, then this 1 is tied to VDD, so that output is 1 only. Next, if pull down on, which means the NMOS is on and pull up is off. So at that time, the output is 0 because whenever NMOS transistor is on, it is connected to ground. So that's why its value is 0. Next, pull up on, which means the PMOS should be on, and pull down on, both are on. We can call output as X. We can also say that crowbar. So next, we're going to see series and parallel connection. So here you have to remember 4 things. First, the NMOS should be on only when its value is 1. The NMOS transistor should be on only when its value is 1. And the PMOS transistor should be on only its gate voltage is 0. So you should remember NMOS is on only its input is 1 and PMOS transistor should be on only its input is 0. And you can say one more condition. So series means both must be on and parallel means either can be on. So let us discuss the series and parallel connection for NMOS as well as PMOS transistor. So here the figure A shows an NMOS transistors which are connected in series having 2 inputs A and B. Here we are having 2 controls G1 and G2. These 2 controls can be chucked out for 4 conditions, that is 0, 0, 0, 1, 1, 0 and 1, 1. So let us check it out for 0, 0 condition. So as we know that whenever you are supplying 1, then only the NMOS should be on. So this is an NMOS transistor, but here we are supplying 0. At that time, it should be open circuit. So that's why it is off. In series means both must be on. Here, both are off. So that's why it is off only. Next condition, if you are supplying 0, 1, 0 means, so this is a NMOS transistor. If you are supplying 0 means it is off. If you are supplying 1 means it is a closed circuit. But here both are not on. Any one is on in series connection. So that's why the output is off. Here also when you are supplying 1, 0, here it is a closed circuit and here it is an open circuit. So it is either, so that's why it is off. So when you are supplying 1, 1, it is an NMOS transistor and it is series. Both must be on, then only the output is on. Next, coming to PMOS transistor, the condition for PMOS transistor is if it is 0, then only it should be on. Next, and for series connection, both must be on. Suppose if you are supplying 0, 0, we know that it is a PMOS transistor and both should be on and it is a series connection. So that's why the output is on. And here we are supplying 0, 1. 0 means it is closed circuit and here it is an open circuit and both are not 0, 0. So that's why it is off. And here also both are not 0, 0. It is off. And here also both are 1 1, but the condition for PMOS transistor is it should be 0. But here we are having 1 1. So that's why here also it is off. Next, coming to parallel connection. So parallel connection, so this is the how the NMOS transistor should be connected in a parallel. So in the parallel connection, so if both are 0 0 means NMOS transistor is off. If and for parallel connection either can be on. So here if you are supplying 0 means it is open circuit, you are supplying 1 means it is closed circuit. Either any one of the input is on, no, so that's why the output is on. Here also either any one, so the output is on. Here also both are 1 1, so the output is on. Next, coming to PMOS transistor. So here 0 0 it should be on, and here also 0 1 it should be on. Here also 1 0 it should be on, but here 1 1 means both are open circuit. So that's why it is off. So here how the NMOS and PMOS transistor should be connected in series and parallel. So the condition for the NMOS transistor should be on, only its input is 1, and the PMOS transistor should be on, only its input is 0. And the one more condition is, so in series both must be on, but in parallel either any one can be on. Next, we're going to discuss the conduction complement. Next, we're going to discuss the conduction complement. So here the figure shows the schematic diagram of an 2-input CMOS NAND gate. The two PMOS transistors which are connected in parallel, and the two NMOS transistors which are connected in series. Here we are having two inputs A and B, and having only one output, that is Y. So here the conduction complement is nothing but the complementary CMOS gates always produce 0 or 1. For example, NAND gate. Here series NMOS, Y is equal to 0 when both inputs are 1. Thus, Y is equal to 1 when either input is 0. So that's why it requires a parallel PMOS circuit. So if you are providing 1 to the NMOS circuit, since it is connected to the ground, so the output is 0. So if you are giving 0 to the PMOS transistor, the output we will going to get as 1. So that's why we need some complementary gates instead of connecting similar transistors. So here the rule of conduction complement is the pull-up network is complement of pull-down. Suppose in the pull-up if you are using PMOS means in pull-down you need to use the complement, that is NMOS. And similarly, in the pull up, if you are using NMOS means in the pull down, you need to use the complement called PMOS. So this is nothing but conduction complement. The one transistor is complement to another transistor. So next we're going to see the compound gates. Compound gates can do any inverting function. The compound gates mainly used in order to reduce the complex functions. So here we are taking a simple example. Y is equal to A into B plus C into D bar. So here we are taking a simple example. Y is equal to A into B plus C into D bar. This one we can also call it as AOI22, because first it performing an AND operation, because first it performing an AND operation, then it is performing an OR operation, next it is performing an invert operation. Since we are making use of two inputs. So that's why here we are having the name AOI22. So here two inputs and here two inputs. So that's why the name as and or invert 22. So we can simply write it as AOI22. So for this example, we need to perform complementary function. So first we need to write the pull up as well as pull down network. So as we know that the pull up network consists of PMOS transistor and the pull down network consists of NMOS transistors. So first, whenever you are having dot operation, we need to connect NMOS transistor in series. So whenever A into B, so this is a pull down network. And here we are having pull up network. So here the pull up network consists of PMOS transistor and pull down network consists of NMOS transistor. So in order to write the pull down network A into B. So whenever you are having A into B, you need to connect the NMOS transistor series. Next, C into D, you need to connect the NMOS transistor again series. Now the pull up network. So A B is nothing but you need to connect the PMOS transistor parallel. Here also C and D, you need to connect the pull up transistors, or we can say that PMOS transistor should be parallel. Next, you need to add this pull up network as well as pull down networks. So when you are